Gentlemen, this is about a new stadium that is being built in Christchurch, New Zealand. The stadium is dubbed as One NewZealnd Stadium. It's still under construction. It is being touted as a state-of-the-art multi-use arena and will cost around $683 million. The stadium will have a capacity of about 30,000 seats for a supporting event and 36,000 for a concert. Okay, so what will I be talking about, and more importantly, why I'm talking about it? Okay, let's see. I will answer it like that. For a student interested in structural engineering and for practicing engineers, it is very useful to observe the construction in general. One get to know how the engineering challenges are being tackled by the peers, which can serve as a starting point for our future projects of similar nature. Uh, with respect to this particular building, I will touch upon these three aspects of structural engineering involved. I will talk about how the roof of the stadium will be supported. I will talk how the supporters that will be coming to watch a game will be safely seated in the stadium, and I will talk about how the out of plan forces generated in different parts of the structure will be transferred. Okay, so I will be talking about the structural framing adopted for supporting the roof of the stadium as discussed earlier. I have worked for you guys about how the arrangement of structural members is there to support the gravity load of spectators, and how the structural members have been arranged to transfer the out of plane forces. Uh, for people who have seen stadium in non-seismic regions, this structural framing, I warn, will may appear to be overdone. I myself have seen structural framing of few stadiums in Europe, and I have also made one video about the structural framing of a stadium in Bangkok on this channel. And to me, at first sighting, the number of members used for this stadium appears way too much. But I think considering the seismic activity of this region, it must be a requirement. Let's look at some of the pictures that I have undertaken. You can notice these pictures and make sense of the structural framing of the stadium. I will talk about these things later as well. Okay, let's start with the basic structural framing to support the roof of the structure. That's how it looks like. I'm calling it a truss frame. It is basically a frame, a cantilever at the top, and arrangement of members in a triangular shape to transfer the loads generated in the upper cantilever part down to the foundation. This basic structural framing is spaced at equal distance along the periphery of the stadium. You can notice that the roof here in this stadium is not supported by a flexible tension members, which is a preferred structural member for many stadiums around the world. I will show you a couple of pictures to support my statement. This one over here is a picture of a Juventus stadium in Torino, in Turin. Here you can see that the roof trusses are being supported by these flexible tension members. I've got another picture of a Wembley Stadium. I think it's in London. Here the roof of the stadium is also supported by a flexible tension members, which are in turn supported by an arch. Okay, this picture over here shows the bracing adopted for the outer chord of the basic frame shown earlier. You can see in that the bracing consists of horizontal members as well as the diagonal members. These blue horizontal members are structural steel members. These diagonal brown members are also structural steel members, while this tie over here is a member in structural rod. It's just a wire, this thing over here. Moving on to the bracing adopted for the inner chord of the basic frame shown earlier. For the inner chord, there are no diagonal members. There are only structural steel members arranged horizontally at 4 different levels. Okay, let's look at these members in actual construction. Let's talk about the out of plane bracing for the inner member of that trussed frame. So this is the inner member over here, this is the inner member over here on the adjacent frame, this is the inner member here on the next frame, this is inner member here in another frame, and as you can see, these inner members are connected by these horizontal circular members at 4 different levels. This is the second level, and this is the third level over here. Can I see fourth level over here in this picture? No, I can't see it here, but you will be able to see it in the next picture. Yeah, you can see it here maybe. Okay, let's talk about the trussed frame here. In the previous picture, the trussed frame was incomplete. That picture was taken a bit earlier. This is the more recent picture. Here you can see that's what the trussed frame is. That's what I had drawn you through a line diagram earlier. Okay, okay. These are the arrangements of members in trussed frame. Okay, now let's talk about the bracing for the inner chord. So this is the first member, this is the second row of member, this is the third row of members, and this is the fourth row of members. So now let's talk about the bracing for the outer chord of this basic trussed frame. These are the diagonal members that I talked about. See, it goes all the way here and then it goes down there till the foundation. This is the tension tie over here. It's not here, it's somewhere here. And this is the second tension tie over here. You can't see it here, but trust me, it's there. In addition, the outer chord has also been braced with these horizontal members, one at this location and one at this location. So this is how the basic framing is to support the roof of the structure, and this is how the bracing framing has been braced for out of plane actions. Now let's move on to the this is another part of the basic framing that I haven't touched upon in the earlier picture. Now let's discuss about it. Let's take a look about what it is. Okay, so at these levels, at this level and at this level, that basic structural framing to support the roof has been braced for out of plane actions in the plane of these members over here and this member over here, and the framing looks something like that. For the framing in the plane of this member, it's like that, and the bracing in the plane of this member looks like that. So this is the additional bracing. This is the additional bracing done for this particular trussed frame. Now let's look at this framing in the actual construction. Okay, here you can see this is the bracing done for the at the top, and here you can see this is the bracing done for at this level. Yeah, sorry for my drawing, it's a bit erratic, but you get the point. Now let's see how the seats have been supported. The seats itself has been placed on the precast stepped slab or stairs, as you can see in this picture over here. These precast members are attached to the diagonal member, which you can also see over here, which in turn is supported by 3 columns of varying heights. Now let's see what I'm talking about here. So these are the precast members. These are the precast stepped slab or stairs, as you might call them. On these stairs they will put on seats. Now this precast member is attached to this member over here, which is going all the way down, this member over here, and this member over here, which is going all the way down. And this member has been supported by 3 rows of column. One row is over here, second row is over here, and third row is hidden behind it, which you can't see here, but you can see here in this member. One row is over here, second row is over here, and third row is over here. Sorry, excuse me. Okay, in addition, this member over here and this member over here has also been connected through these members as well. Now let's get a clear picture of this framing in the next slide. Here there's another picture. You can't see clearly, but I will show you how the seats have been supported for gravity loads. So this is the picture, this is the line diagram, which hopefully gives a clear picture of how the seats have been supported. This over here is a tubular cross section which is directly supporting the precast members, and these green members are the 3 rows of column that I tried to show you in the actual construction. And then there these 3 rows of column have been connected horizontally as well as diagonally, as shown here. Now this diagram over here is a line diagram, which is the diagram in the plane of the diagonal tubular structural steel member that was supporting the precast seats shown in the earlier diagram. You can see over here that this member has been braced for lateral forces by 3 kind of members. One kind of members are going horizontally, one is going diagonally, and then there is a K-brace as well. You can see over here, this is the horizontal line of members. These are the horizontal line of members which are bracing that black member, and this is the braced frame going all the way down here, and there is an additional K-brace over here. Hopefully you can see what I have shown you earlier in the line diagram. So this is the member which is directly supporting the precast members, and this member has been braced for lateral loads through these diagonal members over here. And in addition, in the alternative span, there is a K-brace over here as well. In addition to these diagonal members, this yellow member has also been supported by a group of these members over here, these horizontal members over here. Now let's look at how the outermost line of columns have been braced for lateral loads. For outermost column, again it has the diagonal members as well as the horizontal members as shown over here. Now let's try to find those members over here in the actual diagram. So let's first look at the outermost line of columns. This is the outermost line of columns. Okay, and these outermost line of columns have been braced for out of plane actions through these members as well as these members over here. So they are quite stiff for the out of plane action as well. Now, in addition to the bracing that I discussed earlier, there is an additional set of bracing for the basic trussed frame that I discussed, which is supporting the roof. This basic bracing consists of these members over here. It seems as if this was an afterthought, because as you can see, it does not seem to fit organically into the original construction. Okay, here I've tried to draw your attention to the set of connection that has been adopted to connect the assembly of outer frame, the frame which is supporting the roof, and the structural assembly of the inner frame which is supporting the seat. Now these two separate structural systems have been connected as well, and they have been connected over here. If you look here, see, it's been connected here as well, and it's been connected here as well. And I actually don't understand the reason for connecting them. Maybe they need to impart an additional set of redundancy, but I don't know. But as you can see, there is a connection for you to note. Okay, this is another observation that I wanted to show with you. As you can see over here, there is a provision for seismic cap as well. This over here constitutes a seismic cap. That is understandable, because it's better to break this huge structural assembly into different components so that it can behave in a less complicated manner. Yeah, here in this picture I have tried to draw your attention to that K brace that I discussed earlier, this K brace over here. For me, this does appear to be an afterthought, maybe by a third-party reviewer later during the start of the construction, because these members does not seem to fit organically with that basic structural framing. You can see it here a bit closely as well. Excuse me. This is how this whole stadium will look like once it's completed. Thank you for watching this video. I will connect with you guys hopefully with some more content. Bye.